This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 5, Lesson 8, Basic Machines and Mechanisms, plus the pins that hold a linkage together. 3 ideas. A machine trades force for distance, with no energy of its own, so work in equals work out. A mechanism converts motion through a linkage you analyze with instant centers. And the non-threaded connectors, pins and retaining rings, carry direct shear. We'll close with the degrees of freedom count that tells you how many inputs a mechanism needs. Concept 1. A machine trades force for distance. The handbook prints the conservation of energy law. From it, a simple machine that stores no energy gives back all the work you put in. So effort times its travel equals load times its travel, and the mechanical advantage, the force gain, equals the distance ratio, which for a lever is the effort arm over the load arm. A large advantage just means the load moves a shorter distance. You never beat work. The definition itself isn't printed. Concept 2. Mechanisms convert motion. A slider crank turns a crank's rotation into a slider's straight-line motion. A 4-bar links 4 members. The key tool is the instant center, a point 2 links momentarily share with the same velocity, and the point a link seems to rotate about right then. The pin joints are instant centers. For a slider, one of them sits at infinity, perpendicular to the sliding direction. Know a link's instant center, and its velocities follow as pure rotation about it. Concept 3. Locating instant centers and counting freedom. Kennedy's rule says any 3 bodies share 3 instant centers that all fall on one straight line. That line locates an instant center you can't spot directly. The number of instant centers is n times n-1 over 2. And the modified Grubler equation gives degrees of freedom from the link and joint counts. Pin joints remove 2 each. Roll slide joints remove 1. A 4-bar works out to a single degree of freedom. Concept 4. Impact and restitution. When 2 bodies collide, one number, the coefficient of restitution, sets the bounce. The ratio of relative velocity after to before, measured along the impact normal. It runs from 1, perfectly elastic with full rebound and energy conserved, down to 0, perfectly plastic, where the bodies move off together. Momentum is conserved through the collision, regardless. Restitution only fixes how the relative velocity reverses. Concept 5. The pins that hold it together. Pins, clevis pins, and retaining rings are the non-threaded connectors in a linkage, and they fail in direct shear. The same formula the handbook gives for bolts and rivets, stress equals load over area. The catch is how many planes carry the load. A pin in single shear has 1 plane. A clevis pin is cut by 2, so its area doubles and the stress halves at the same load. Rigging lugs and shackles are rated hardware. Setup. The worked problem. A Class 1 crowbar has a 24-inch effort arm and a 4-inch load arm, worked by a 60-pound effort. Its fulcrum rides on a 1/4-inch clevis pin in double shear with a 6,000 psi allowable. The plan. Mechanical advantage gives the load lifted. Then the fulcrum reaction, the sum of both downward forces, loads the pin, which we check against the allowable. Solve. Part 1. Leverage. The mechanical advantage is the arm ratio, 24 over 4, so 6. Moment balance turns the 60 of effort into 6 times that, 360 of lift. The work check confirms it. The handle travels 6 times as far as the load rises, so work in equals work out. This is the ideal frictionless advantage. A real drive gives some of it back to efficiency. Solve. Part 2. The fulcrum pin. Both forces bear down on the beam, so the pin reacts their sum, 420. The clevis puts the pin in double shear, 2 planes, so the area doubles. The stress comes out near 4,300, comfortably under the 6,000 allowable, so the pin is safe. Forget the double shear and you'd compute over 8,500 and wrongly reject it. Traps. 5 ways this bites. 1. Double shear means 2 planes. Use 1 and the stress doubles. The biggest pin error. 2. Mechanical advantage is ideal and frictionless. A real drive loses part to efficiency. 3. An instant center is instantaneous. It moves as the linkage turns, and a slider sits at infinity. 4. Grubler counts joint type. Pin joints remove 2 degrees of freedom. Roll slide joints 1. Don't lump them. 5. Restitution is a bounded ratio from 1 to 0, and momentum conserves either way. Quick recall. Mechanical advantage is the arm ratio, built on the conservation of work law. Memorize the definition. Restitution runs 0 to 1, elastic to plastic. An instant center is the point 2 links share. Kennedy's rule puts 3 of them on a line, and the count is n times n minus 1 over 2. Grubler gives degrees of freedom from links and joints, and a pin carries direct shear, stress over area, doubled planes for a clevis. Golden rule: a machine trades force for distance, but never makes work. Next up, Topic 9. Mechatronics, motors, and engines. The linkage moves, but something has to drive it. Lesson 9 turns to the electromechanical side. The electric motor and its synchronous speed and full load torque. The sensor controller actuator loop of mechatronics, and the internal combustion engine rated by mean effective pressure. Everything is at pprepengine.com. Cheat sheet, word solution, and a quiz attached here. If the course helps, subscribe.
The full study guide, with every equation and common exam trap, is free at pprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.